Alright, so you may wonder why there wasn't a video for you to watch at home for this section, but basically it's a continuation of 4-3. It's just slightly harder, so I say harder. That's not really the right word. It just is a little different. Basically now we are solving basically the equations of the form ax squared plus bx plus c is equal to 0 by factoring. So we've been graphing them. Okay, now we're going to be factoring them. So basically the difference now is we have a number here. Before we just had this, which basically just means it was a 1 in front. So now we have to multiply a times c and get factors of that give me b when I do this. So, and it's going to have some different techniques within it, but honestly there really weren't any notes, so it just wasn't worth making a video for you guys to watch for like just an example problem when it just made more sense for you to do it in class. So, we're going to run through some examples here, and hopefully you understood 4-3, because if not, this section is going to be probably a little bit more difficult because of it. So, number 4, we have 3n squared plus 7n plus 4, and it just wants us to factor. So, the way I like to look at these ones is basically I make a factor tree with whatever numbers are here. So I don't like go through and say, okay, well this is 12 and start with 12 at the top. I literally just start out making my branches and saying, okay, 3 and 4, 2 and 2, okay, and I figure out what factors add up to it. So I could have my 4 and 3, which is going to work. I could have 3 or 6 and 2, okay, all different options, but 4 and 3 are going to work. Now, you don't write these down the same way. You don't say, oh, 3n squared plus, or 3n plus blah, blah, blah is equal to, like, we don't do it. We have to show a step here. It's not optional, okay? It's confusing the way I just said it because you can't even do it that way. So, you want to match up these numbers as best as possible with these, especially if they're not the same, okay? Like if I had, let's just say this was a 6 and an 8, I would want to put the 6 with the 3 and the 8 with the 4 because that's the most logical thing for something that I can pull out to make my life easier, because we're going to ultimately have multiple steps that come in with this. I know that sounds confusing, but once we do some examples, I think it'll make more sense. Okay, so 3n squared plus 3n plus 4n. So basically I just split this into two things that multiply to give me whatever that value is, plus 4. Now we do what's called factor by grouping. Okay, so basically you're going to take these first two terms and these last two terms and pull something out of them. So what is the biggest thing I can pull out of this? I have a 3 in both, I have an n in both, I have an n squared here. So I'm going to pull out a 3n, which is going to leave me with n plus 1. Here I can pull out a 4, so n plus 1. If these do not match, something is wrong. These have to match, okay? So then I write down everything that's left outside. So 3n plus 4, n plus 1. Okay, and that's when I'm done. Okay. And if you need to use colors to group stuff, that is completely fine. 6p squared plus 5p plus 1. So I need factors of 6 and 1 that give me 5. So 6 and 1, 2 and 3. So basically 3 times 2 or 2 times 3. Okay, different options there for what I have. That will work. So it will be 2 and 3. Now, this is one where it really doesn't matter, technically speaking, which factor you put with the 6. I would say always go with the bigger number, so I'm going to go with 3. So I'm going to go 6p squared plus 3p plus 2p plus 1. Now we're going to do this factor by grouping again. Okay, I'm going to try to keep my colors here together so you guys can see what I'm doing. as best as possible. So I need to figure out the biggest thing I can pull out of both of these pieces. I have a 3p here, I have 6p squared here, so I can definitely pull out a 3 from both pieces. I can pull out a p from both pieces. So 3p times, that's going to leave me with 2p plus 1. Here I can't, technically speaking, pull anything out, so I'm just going to pull out a 1, and this is going to be 2p plus 1. Again, these have to match, so 3p plus 1 times 2p plus 1 is the answer. Alright, so those are some of the easier ones that factor relatively easy. Let's see if I can get one that's a little harder to factor. Let's go with 10. So 14m squared plus m minus 3. So I have factors of 14 and negative 3. Okay, so basically I have to have something that's negative here, but it's going to be a big positive and a small negative value that are going to add up to be my m. So 14 can break down into 2 and 7. So basically I have the option of 21 and 2, 14 and 3, or 6 and 7. Well, 7 minus 6 would give me 1, and these are factors of 3 and 14. So I'm going to use 7 and 6. It makes the most sense to put 7 with 14 and then 6 with 3. So I'm going to do 14m squared plus 7m minus 6m minus 3. So then I will factor by grouping. So here I have 14 and 7. I can pull out a 7, and I can also pull out an m. So 7m. 14 divided by 7 is 2m plus 1. Over here I can pull out a negative 3 to be left with 2m plus 1. Again, these match. So 7m minus 3 times 2m plus 1. Alright, so these are just the normal factoring ones. Okay, we can get down into some harder ones. Factoring the expression is the next thing. Okay, and also, sorry, by the way, these can still possibly not factor. Okay, it is possible that something won't be factorable. If it is, just say not factorable. Anyways, now this next type is going to be back to the special types, okay? So think back to our special types in the last section, difference of squares and perfect square trinomial. So these are going to follow that same pattern. So 14 is 4r squared minus 25. Okay, so if you need to think about it the way we were thinking about them the other day, you can do that. This is going to be 2 squared r squared minus 5 squared. So this is a difference of squares, so I'm going to have 2r plus 5, 2r minus 5. And I'm done. You don't have to do anything else with those ones. $16s squared plus 8s plus 1. Okay, this is going to be a perfect square trinomial. So this is 4 squared s squared plus 2 times 4 times s plus 1. So I am going to have 4s plus 1 squared. Okay, this is following the pattern from the perfect square trinomial. All I'm doing is breaking this down, thinking about this as 4 squared. Okay, and this would be 2 times 4 times s times 1. Okay, just so you can kind of see what's going on there. Let's see. It's probably pretty good on those. So we can have problems where we have to actually factor something out first to be able to do the problem. So that's something like 22 through 30. So starting with 22, we have 12x squared minus 4x minus 40. So the first thing I want to check is, can I factor anything out of this whole thing? And I'll give you a hint, in this section you pretty much always can in this 22 through 30 part. Okay? So what's the biggest thing I can take out? Well, I have a 4 here, and that's the biggest thing I can really take out because I don't have an x in every term. So I'm going to pull out a 4. So 4 times 3x squared minus x minus 10. So now I only have to factor this, but do not lose this number out here. Okay, you cannot afford to lose that number. That is very much part of the problem. So I have 3 and 10, 2 and 5. Okay, so I could do 3 times 2 is 6 minus 5, or negative 6 plus 5 would give me negative 1. That would be my best option. So I have a 6 and I have a 5, so I'm going to want the 6 lined up with the 3 and the 5 lined up with the 10. So I'm going to keep this 4 out here. 3x squared minus 6x plus 5x minus 10. Okay, and when you're done factoring, these are the ones where I definitely recommend checking them, especially not being able to ask questions really, because I can't be here to be like, oh, this is what happened, or yeah, that's right or wrong. But you can check it right away and know if you did it right. Okay, and then you can check the back of the book too, just to verify that you did it. So 4 staying out here. I'm going to probably do brackets just because I think it's easier. Here I can pull out a 3x, leaving me with x minus 2. Here I can pull out a 5, leaving me with x minus 2. Again, these still have to match. Okay, I'm going to say that over and over again, because a lot of times people end up not having these matching, and it doesn't work. So then I have 4 times 3x plus 5 times x minus 2. Okay. So basically with these ones, you're just looking for something you can pull out first. Now, the last ones here, okay, the only reason I'm not doing any more of these is because basically you're just looking for something you can pull out and then you factor. So you should be able to do that without me really doing any more examples, hopefully. But always check that first, especially in that section. There's always something you can pull out, and it could still be a special type. Like 26 is a special type. I'll actually run through that one really quick. So 26, 12m squared minus 36m plus 27. Okay, initially looking at it, this does not look like I have a special type. It doesn't look like there's anything here. Like this isn't, like 12 definitely isn't something squared, so that's not a special type. However, I can pull out a 3 from each piece, and it might make it a special type. So if I pull out a 3, I'm left with 4m squared minus 12m plus 9. Now all of a sudden I have a squared piece here and a squared piece here. This is now a perfect square trinomial. So then I can go straight to 3 times 2m plus 3 squared. Oh, minus 3. Sorry, this sign's negative, so it's going to be minus. So 2m minus 3 squared. Okay, so that's just how you can notice those special things, and how pulling something out might even lead you to something easier, because I really don't think you want to find the factors of 12 and 27 that give you negative 36. That's just a pain, and you're not going to want to do that, so always pull something out first if you can. Sorry, I know I'm moving kind of fast. I am trying to get these in before I actually leave, because I'm obviously recording these prior to leaving, so try to knock these out really quick. Basically, I'm only going to do one of these solving equation types because we did them in the last section, and as long as you can factor in this section, you are good to go. I'll do 36. It's a little harder. So 4x squared minus 20x plus 25 is equal to 0. So I need to factor this. First and foremost, can I pull anything out? Well, this is 4, this is 20, and this is 25. A 4 could come out of here, but a 4 can't come out of here. 5s could come out of here, but 5s can't come out of either of these. 2s can't come out, so I'm just going to have to factor it as is. So I'm going to have to factor 4 and 25. It's going to be 20. 5 and 5. Now I've got to figure out what factors can do this for me. So I had 4 and I have 25 and I need negative 20. Well, maybe y'all noticed. Hopefully you did, because I didn't until just now. But this is a special type. This is a perfect square trinomial. So this is just 2x minus 5 squared is equal to 0. Now take the square root of both sides. So 2x minus 5 is equal to 0. 2x is equal to 5. X is equal to 5/2. I'm going to try not to give you guys ones that really are fractions if I can help it, but some of them are just going to be, and when I say fractions, it's going to like result like this, where you just divide and you get a fraction. So you might get 1 or 2 of those, but that's it. So basically, still just factor this the same way. Set it equal to 0 and solve for the variable. So your problems to go with this section are going to be (3 through 27, every other odd, and 33 and 37. So that'll be your problems. You need to finish those today because you do have something else to work on tomorrow. There will be no video for 4 or 5, at least for a little bit, because we're going to have a quiz when I get back. So Wednesday we'll review when I get back, and we'll go from there.